Assalamu alaikum.
Walaikum Assalam, Naufal. How are you?
I'm doing good. How about you?
I'm good. Just give me a moment, guys.
Yes.
All right, boys, let's begin. Naufal, yesterday you weren't here. We started off with series. All right.
Okay.
In today's class, we are going to move forward with geometric progressions. All right, Naufal.
Yes.
Okay. Parsa, we did this question yesterday.
Yes, we did.
All right. I have not written down the answers. I think you told me. And I think I told you that they were correct as well. Today, let's begin geometric progressions. So, contrary to arithmetic progressions, your geometric progressions, they are very simply similar to your arithmetic progression in the sense that it is a progression. The only difference is that the terms of a geometric progressions increase or decrease when you multiply or divide the previous term with a certain number. All right. In arithmetic progressions, we add or subtract in order to get to the next term. In geometric progressions, we are going to be what you may call multiplying or dividing in order to get to the next term. So, for example, we saw above that AP progressions. Oh, AP is different from GP in the sense that you have what you may call the term of the progression. They are simply increasing or decreasing by the same magnitude, but that in magnitude is being added to it. Now, what's going to happen is that that magnitude is going to be multiplied into it. Like, for example, if we write down, if we try to explain to someone what are geometric progressions, it is simply your terms are, you know, you multiply by a fixed amount. So, terms, or you can say that simply. Consecutive successive terms, actually. That would be the right word. So, successive terms are found in a sequence by multiplying or dividing. Usually, it's multiplying with a common magnitude. So successive terms are found in a sequence by multiplying a common magnitude. So whatever magnitude, whatever number there is, it's supposed to be common throughout, and you're supposed to be multiplying that in order to find, successive term. All right. This common magnitude, before it was known as the common difference. Now, because you're multiplying with it, and it's going to remain throughout the course of your progression, this is now going to be known as your common ratio. And it is going to be determined it is going to be your common ratio, and it is going to be determined by, for example, denoted by a lowercase r. Now, for example, let us take an example. Above we only have AP. I thought I had written down a geometric progression. So, for example, I'm going to use a very simple example. 24, 48. Mm, This is a sequence. It is very common knowledge to me that the terms are increasing by multiplication of 2. All the terms. Oh, there's an increase in every term by simply just multiplying the previous term by 2. And this right here is going to be your R, which is your common difference. Similarly, if I want to find the nth term of a particular sequence, how will I find that? The nth term of a geometric sequence is going to be simply found by you multiplying the first term with the common difference, with the common difference raised to the power n minus 1. And we already know what is n, what is a. A is your first term, n is the number of terms, and stuff of that sort. All right, now usually students say how to find r. All right, because this is different too. This is not like the previous parts. So if you want to find r, r can be simply found by what you may call the second term, dividing it with the first term. That's how simply r can be found. And this is how simply your nth term is going to be found. Clear, boys? Anything that you don't get?
No, sir, I guess it.
It's like very simple, guys. Like I think you guys should have done this in IGCSE too. I am sure about it. All right. And similarly, you're going to have to calculate R, because in the common difference calculation is not difficult. If you want to calculate the common difference between two terms, that is fairly easy to do so. But the only issue is that, if you want to calculate the common ratio, then obviously you have to divide the terms. Before, you're just simply subtracting them, and the common difference is actually much more easily visible rather than the common ratio, because the terms are, increasing exponentially. All right. If we're using the same example, we can simply continue this forward with what you may call, if I say that find the eighth term. Similar to what we've used above, where we took some questions and you just have to put in the formula. So how you're going to use the formula, it is very simple. It is extremely simple. I think these guys are a bit more easier to do, GP expressions. So if we're trying to find the eighth term, it's going to be ARN minus 1. What is the first term? 24. R is 2. N minus 1, it's going to be 8 minus 1 raised to the power 7. Yes, guys. Can you please tell me what's the answer? Yes, boys.
It's 24. Oh, wait.
Of what?
9, 2, 7. It's 3072.
Wow. That's a big answer. Wasn't expecting it to be that big, to be honest.
Yeah. Mr. How do we find the sum of all the terms?
Yeah, that is what we're going to do next. I'm going to use the same example to go for the sum. So this was 3072 something. All right. Now, usually what happens is, what if they ask you to find out the sum of terms? So just as we did above, where we found the sum of n terms, now we're going to do it again. So it's going to be, if you're trying to calculate sum of a particular number of terms, so sum of n terms, it's going to be what you may call Sn is equal to A times Rn minus 1 r raised to the power n minus 1 over 1 minus r. Now, one thing that you guys need to know is that r cannot be equal to 1 over here. Otherwise, you're dead. You're going to end up dividing it by 0. So, and this is r raised to the power n. It's not r multiplied to n. I want to make sure that that is clear. This is r raised to the power n. Why does my r look weird? No, it looks okay. All right. And what is going to happen simply, and this is how you find the sum of n terms. And it's very, very simple. It's not that difficult at all. But what if your r is less than 1? This is for all the sequences in which your r is greater than 1. Usually. In sequences which have r is less than 1, that means that the sequence is decreasing. For example, the sequence was 10, 1, 0.1, 0.01. Like you have a sequence like this, you're dividing by 10 or you're multiplying with 1 over 10. In those type of sequences, you guys will probably notice that after a while, the sequence will become too small. It will probably become 0.000001, and then the next term will be 0.000001, and so on and so forth. So the terms are going to be moving forward. What happens to in these type of sequences is that after some time, you try to or you stop considering these numbers because these numbers are so small and so negligible that we try to consider that the sequence has merged together. The sequence has converged. We call it a converging sequence. What are converging sequences? in which the terms they either get too small, that what happens is that you simply what you may call consider the different terms of the sequences to be equal. They'll become so less difference between them because obviously you're multiplying them with a certain ratio, so their difference is not going to be common. So in these type of sequences, we call these sequences converging sequences, such that what happens is that they become so small to each other, or their difference becomes irrecognizable. So what you try to do is that you consider that the sequences merge. Now all the terms are same. All right, because otherwise, a sequence which you're dividing by 10, for example, that is going to continue on and on until you have a million zeros before you, and the next term is just going to have one more zero than the previous term. And the number is so small that it's almost negligible. We'll just say that it's zero. All right. So the terms keep on start to repeat themselves. All right. When you round them off and stuff, the terms begin to repeat themselves. And we say that these terms are known as for converging sequences. We say that these terms are of a converging sequence. Is this clear, Parsa and Nopal?
Yes.
Yes, sir.
Nopal, is this clear? Okay, all right. So converging sequences, they're the same, like finding of the nth term is the same for a converging sequence, but its sum is different. So for converging sequences, what you're going to do is, it is known as, first of all, it is known as sum to infinity. Because all the terms are equal in the end, so it becomes almost sum to infinity. And where r itself is not equal to 1, it is less than 1 and minus 1. Oh, greater than minus 1, less than 1. I hope this is clear. And what's the difference in the formula? First of all, it is written like sum to infinity. And you do it like this. That is simply how you're going to do it. Is this clear, boys? For geometric sequences, you are supposed to find some, you can find it in two ways. One is for a regular geometric sequence in which you find the sum of n terms. For a converging sequence, or even if it's not written that it's a converging sequence, sometimes they just simply say that it's the sum to infinity. Then you already know that it's a converging sequence, it's a geometric sequence, but the common ratio is less than 1. So that is going to be the case. Is this clear, guys? Anyone who still does not get this?
Clear, sir.
All
Yes.
right.
Clear.
Okay. Now,
But Mr. I don't get the R can't be
one.
like, yeah,
What's if r is equal to 1, 1 minus 1 is 0.
right.
Then the
And
sum
what
becomes
about
infinity.
the one below it for the sum of infinity, where
Mhm.
R has to be greater than minus one, but
And less than 1.
less than one?
Only then will you be able to get a sum to
In the
infinity.
example you gave us, the ratio
Mhm.
was greater than one.
Oh, okay, for this example, you're obviously going to be using this formula and this formula because the r is greater than 1, and it's a simple ratio. We have not mentioned that you can okay, you use the formula for this, that we've not mentioned that it's the sum to infinity or something of that sort. So find the sum of the first 15 terms. Yes, boys. Kindly solve it and let me know. You have to find the sum of 15 terms. This is the original terms. And let me know if you've written the question down. So I'll take out a past paper question. Written down?
Wait, mister.
Take a screenshot, guys.
Yeah, that's what I'm going to do.
Sir, also can you post this notes link? I also messaged you on WhatsApp, but you did not see the.
Oh, sorry, no fun. Well, let me check.
Because I messaged you about where can I find all these notes. I was going through, but I think it was in old classroom link maybe.
Hmm. Okay, I
Can't
just
get
saw
the
your
updated
message. Yeah.
one.
Apologies, Nofal. I completely did not see it. I don't know why. I think you messaged me on a Friday.
Yeah,
And yeah,
maybe on
usually I don't
Friday,
check my phone
Thursday.
on Fridays
Okay.
because I was a bit busy on this Friday. I had a few guests coming over. And I think the other messages piled up and your message went really down. So I'll post the notes. Yeah, Pastor also reminded me.
Okay.
I'll do that too. All right. Hopefully, you guys have written down the questions. All right. Did you guys find the sum of that question? Yes, Parsa. Yes, Nofal.
So you didn't post the question.
No, the previous one. This one.
Oh my. So all this time I was waiting for like a past paper question, but it was
That
displayed
is also here.
time.
No, don't worry. The past paper question is also here. I'm
Oh, okay.
asking you what is the answer to this one. It was very simple. Okay, I'll tell you what the calculation is. So you're just simply going to be like S15 is going to be 24 because it's A times R, which is 2. N is 15 minus 1 over 1 minus 2. There is one thing that you guys did not spot.
How is the sum negative?
Well done, person. Yes, one thing I was hoping for you guys to spot. Wouldn't the sum become negative if r is greater than 1? Yeah,
Yeah.
what should we do?
Um. So we take like the opposite of the ratio.
No,
Oh.
I'll explain it to you. When r is less than 1 for a normal, uh, you can say expression or progression, then you will use this formula. And when r is, guys, by the way, I think you guys have done this in IGCSE too. I think this is in the syllabus, if I'm not wrong. I'll have to check.
Yes, it is.
It is in the syllabus, right?
Yes, yes.
Let's see, someone did not remember it. Nopal telling us so proudly that he forgot. No worries, Nopal. What you're simply going to do is that this formula is just going to repeat itself. The only difference is that you're just going to tweak it. Tweak it how? Flip the switch. But if I do this, what will happen to my, what you may call, progression? Obviously, it cannot be the same. Clear? One thing that you guys need to know is that always remember one thing, that whenever you're trying to find the arithmetic uh, progression, geometric progression for, oh, sorry, the sum of terms for an geometric progression, you're supposed to use the formula according to what your R is. Is this clear, guys? And I will tell you also one trick I will also let you know. This formula is probably not going to be used. Why? Because whenever your common ratio is going to be less than 1, you're going to be using the sum to infinity one. Usually they will tell you that in the exam. All right. So one thing that you guys need to remember is that simply whenever your common ratio is less than 1, you're simply going to be using this formula. And whenever it's going to be greater than 1, you're going to be using this formula. Is this clear, boys? Wait, oops. Now, where should I put the, what you may call, should I show you guys the question or what should I do?
Yeah. So can you show us the question?
Hmm.
And so can you also scroll up?
Yeah. Also, one more thing that you guys need to point out is how can these two be the same two? How can I just simply convert this? So I was hoping that you guys would notice this. This is also going to be the inverse. If you guys remember, when it's 1 minus r, it's also 1 minus r raised to the power n above. All right.
Okay.
So this is for when your common ratio is less than 1. This is for when your common ratio is greater than 1. You're going to be using this formula now. So it's going to be 2 minus 1. Clear? So that is going to give you your sum, which is probably going to be something. I don't know. You guys have to check. Is this clear, boys?
Yes, sir.
Yeah.
All right. Now, feast your eyes. Whoever does this question, I salute you. This is a good question. A lot of information has been given to you, and it's 6 whole marks. So keep that in mind that you are solving a question worth 6 marks. That's a lot of marks for a simple arithmetic APGP question. That is a lot of marks because usually questions from this chapter, they are higher in length when you are doing what you may call your binomial expansion and theorem, and those are the difficult ones. But this is a 6 mark past paper question, and this is going to be given to you guys as homework.
Okay. So
Yeah,
I saw this question this morning.
I hope you didn't do it.
Yeah, I didn't do it. I'm like, this looks too
Okay.
hard. I'm gonna skip it.
Okay. Yes. Okay. And in the end, when I will do this question with you, this is the first question that we're going to do in the next class. Also,
Okay.
do not look into the mark scheme for this. Even if you guys do, it's not going to be really helpful. I I cannot understand the mark scheme no matter what I do. It's just
Even
always very
the
weird.
question, like what, like the third term of the geometric progression is equal to the second term of the arithmetic progression.
Yeah. See, you're supposed to find the third term of the geometric progression, and you're supposed to put it equal to the second term of the arithmetic progression that you will find. How will you find those? Well, if I knew the answer to that, we wouldn't be here.
Yeah.
A mystery. All right, boys.
All
No
right.
fun. Will you be able to do it?
I think yes. First we will basically substitute it in a question, right?
Yeah, you can try that. I'm trying to be creepy. All right. Why does this look like Chinese New Year? I don't know. Yes, whatever you do. Okay. Should I, guys, take a screenshot? I'm not. I'm too tired to post it on Google Classroom.
Yeah, I took the screenshot.
Nopal, can you do that too?
Yeah, I did too.
All right. This is homework till the next class. Beware.
So, Mr. We're done
Yep.
for today.
I'm done for today.
Oh,
I'm ending quickly today. I don't know why. All right.
all right. Bye, Mr.
Bye bye. I love this.
Allah
Have a nice
Hafiz.
week, guys. I love this.
Bye.
Bye bye.
Yes.